What a beautiful day. We are here once again. Why are we here? We want to enjoy another meal from Mathematics Meal. Welcome to Mathematics Meal. I'm still your friend and brother and also your tutor, Engineer Ike Okechukwu. In our previous video, we looked at Theorem 1 on circle geometry. That is this particular theorem, the angle that an arc subtended at the center of a circle is twice that which is subtended at any part of the wall of the circumference. Yeah, that's what we looked at. We were able to describe this theorem and explain it to a certain degree that everyone can actually understand it. Have you subscribed to our YouTube channel? Please just hit the subscribe button. Subscribe to our YouTube channel at Mathematics Meal 1, and then follow us on Facebook at Mathematics and Science Meal, and also follow my Facebook page or my Facebook profile, Engineer Ike Okechukwu. There you will see a lot of meal in mathematics and in sciences that can keep you healthy. Alright, like we said in the last video, we are going to solve problems on this first theorem. Remember, in the previous video, all we did was to look at this theorem and to explain it. So if you have not watched that video, rush now and watch the video so that you can understand the calculations we want to do now. Let's begin this wonderful journey. Example 1. We're asked to find the lettered angles in the figures below. So we have question A. Okay, let's call this one question B. Let's call this question C, and let's call this question D in our example 1. Okay? Find the lettered angles. That means the lettered angles here. The lettered angle is A, here B, here C and D, and here E and F. So we are required to find the lettered angles. Now you see that the way we design this is that all the equations we are going to solve now will just be based on this theory. Yeah, just on this theory. So let's begin our calculation. Let's start with question A. Alright, we're asked to find A. If you look at this, just is direct, very direct. We have said that twice angle at the circumference is equal to angle at the word center, provided the angle at the circumference and the center, they are produced by the same arc. And if you look at angle A, this is the arc that produced it. And if you look at angle 38, this is also the same arc that produced it. So based on that, this theory will be used, will be applied here. So A will be twice angle at the word at the circumference. Why? The arc that produced A is the same arc that the arc that produced A is the same arc that produced what? Angle 38. So to find A is equal to what? 38 degrees times 2. That is 2 times 38 degrees. Reason for that, twice angle at the circumference equals angle at the center. In short form, subtended by the same word, by the same arc. Remember, that's the emphasis. The emphasis is on subtended by the same arc. That means the two angles must originate from the same word, arc, for this rule to exist. So it means that A will be equal to 2 times 38 will give me what? 76 degrees. So A is equal to 76. It's that simple, very simple. Okay, we'll look at this. This is another circle. This angle at the circumference, this one is angle at the center. Now let's check whether the angle at the circumference and the angle at the center, whether they originated from the same word, from the same arc. Look at this angle. Look at the lines that form the angle. Look at the arc. So these two lines, they originated from this. Okay, so the arc that subtended this angle B is this arc, and it is the same arc that also subtended angle 132, which is angle at the center. So the arc that subtended angle at the circumference, angle B at the circumference, is the same arc that subtended angle 132 at the center. So we apply this theory. So what it means that twice B will give me what? 132. So 2B is equal to 132. Why that? What's the reason? The same reason here. Twice angle at the what? At the circumference equals angle at the what? At the center. So twice angle at the circumference equals angle at the center. So we can solve this. Solving for b becomes 132 divided by 2. So b becomes 61. That 66, sorry, 66 degrees. That will be our b, 66 degrees. Okay, that's very simple. Okay, I believe you have taken this down. So let's solve question C. We are looking for C and the what? And D. Okay, let's clean this so that we can solve question C and D. And C and D. Okay, question C. We are looking for C and D. C is angle at the what? At the center. D is angle at the circumference. And 25 degrees is angle at the what? Circumference. So we move from the known to the unknown. How can we use this known angle to find C? We check the relationship between them. Is there any relationship between this and this? Yes, there is. And that is this theorem. That twice angle at the circumference is equal to angle at the what? Center. And we have checked. We discovered that the angles, they originated from the same word, from the same arc. Look at 25, look at the arc that produced it. And look at this C, angle at the center, is the same word, the same arc. So the relationship between this and this is that twice angle at the circumference is equal to angle at the center. And why we're able to say that is because both angles originated from the word, from the same arc. That's why this theorem can be applied here without any problem. So I can comfortably say that C, twice angle at the circumference, so C will give me what? 2 times what? 25. Because twice, let's write down a little, C will be equal to 25 times 2, or 2 times 25, because twice angle at the circumference equals angle at the center, subtended by the same arc. Angle at the center, subtended by the same arc. You know, we can stay as subtended by the same arc, but already we have established that they were produced by the same arc. So C becomes what? 50 degrees. Now this angle at the circumference, this is an angle at the circumference. So we have found C. We can use this C to check the relationship between C and what? D now. You know, these are the circumference, these are the circumference. Although there is another theorem that can connect these two directly, but we are not going there yet because our interest is on this particular theorem. Everything we are doing is on this. So these are the center, these are the circumference. We know C already as what? 50 degrees. And these are the circumference. Is there any relationship between these two? Yes, there is. That's the theorem. Twice angle at the what? At the circumference is equal to angle at the what? At the center, provided they are subtended by the same arc. And you see angle D, look at the arc. That same arc that produced C is the same arc that produced D. Therefore, 2D will give me what? C. So we can now say that C is equal to 2D to enable us find what? Find D. Reason, twice angle at the circumference equals angle at the center, was angle at the center. So what is C? We have found C to be 50. So 50 is equal to 2D. Dividing both sides by 2, we are going to have 25 degrees. 25 degrees is equal to D. So D is equal to 25 degrees. Wow. So you see, when you understand this particular theory, you will not find it difficult trying to apply them in solving what problems. So we have one more to go, just one to go. Okay, let's use this part of the board for that. Let's use this for that. Okay. Okay, we look at this question. Very beautiful question, a beautiful question. Now we are looking for E and F. If we know E, we can easily find F. Why? Applying this theory. Twice angle at the circumference is equal to angle at the word center if they are subtended by the same word, by the same arc. And truly, E and F, they are subtended by the same word, arc. Look at the arc. From here to this place, that is the arc that produces F. And it is that same arc that produces angle what? E. So, we can comfortably say that 2E is equal to what? F. Twice angle at the circumference equals angle at the center. But the question now is, we don't know what? We don't know E. So what are we going to do? But they gave us a particular beautiful angle somewhere there, 125 degrees. Yeah, a wonderful angle that they gave us. So we can actually use this angle to find E. You know, sometimes we need to think outside the box. You need to do that from time to time. When all that you know has failed you, then you check the ones that are within what you know. Now, all the things we have been doing is this theorem. The angle that an arc of a circle subtended at the center is twice the angle which is subtended at any point of the remaining part of the world, or the circumference of the circle. That's what we have been doing. But now, we cannot apply that alone. We cannot. So, the knowledge of plane geometry, angles and lines will now play a role here. If you notice angle E and angle 125, you see, if you rely only on this now, you cannot solve this problem because we don't know E. And for us to find F, we must get what? We must get E. Yes, we must get E. So, we cannot rely only on twice angle at the circumference equals to angle at the center, because the angle at the circumference we will use to find the angle at the center is also an unknown. So if I write 2E is equal to F, and we have not calculated anything, we have not determined any of the angles. And that's why the person that gave this question, they gave us an angle. So that you apply the knowledge of your word, plane geometry, that adjacent angles on a straight line, this is a straight line, adjacent angles on a straight line is what? 180. The sum of adjacent angles on a straight line is 180. So that's the first thing I have to do. So first I will say that E plus 125, that's question what now? D is equal to 180 degrees. Reason, sum of what? Angles, that's adjacent angles on a straight line. That's the reason for doing that, for saying this. So E now will give me 180 degrees minus 125. So E becomes what? 55 what? Degrees. That's my E. And once I'm able to get E, F is now known easily. We can now say that F is 2E. We remember our theory. Twice angle at the circumference equals angle at the center if they are subtended by the same word, arc. So what is my beautiful E? We have found E to be 55. So this will be 2 times 55, and F becomes 110 degrees. That's my F, 110. Wow. I believe with these examples, we have also explained further the concept of this theorem 1. All you need to do is to look for more questions to solve in this particular theorem. Pick up other mathematics textbook, can be your essential mathematics, new general mathematics, new school mathematics, any of the mathematics textbook. Just pick the mathematics textbook, search for circle geometry, then concentrate only, because we have not done other theories anyway, so concentrate only on the one, on the theory, this particular theorem, that's twice angle at the center is twice angle at the circumference is equal to angle at the center if the two angles are subtended by the same arc. So solve as many problems using that particular theory. So so that when we now do the next theorem, you can now go further to solve questions on that part, on those theorems that you are yet to consider. Okay, till I come your way next time, remember there is need for you to subscribe to our YouTube channel, very important, and also follow us on Facebook. If there is any topic you want us to treat, if there is any topic that you want me to treat in mathematics, a topic you are finding difficult, can I see it in the comment section? Just drop it in the comment section, and right away you will have a comprehensive video on that topic. My business is to make sure that you understand mathematics. My business is to make sure that you understand physics. My business is to make sure that you understand chemistry. And my business is to make sure that you understand all the sciences. I just want you to know sciences, and that's my business. And as you continue to watch our videos, you'll be well grounded in these areas. You will know much about mathematics, about physics, about chemistry, about biology. I bet you will know more. Thank you for following us till now. Till I come your way next time, keep excelling in mathematics and in sciences. I love you.